Good morning, students, and welcome to this last part of the lecture series on stereochemistry. In today's class, we are going to study about the different conformations of butane. This is the butane molecule with a molecular formula C4H10. As you can see, there are 4 carbon atoms here represented by the black balls. Each of these carbon atoms are sp3 hybridized and has a tetrahedral bond angle of 109.5 degree. To understand the conformational analysis of butane, we have to focus on this carbon-carbon single bond. This is the first carbon, carbon 1, 2, 3 and 4. We have to focus on C2C3 bond to study the different conformations of butane. Right now, the conformation in front of you on screen is the staggered conformation. As you can see, all the bonds of butane in this conformation are clearly visible. We have to perform the rotational operation about this carbon-carbon single bond, that is C2C3 single bond. So, if this is the second carbon and this is the third carbon, we have to hold the molecule in such a position that C3 is eclipsed by the carbon number 2. In this position, you can see the two other CH3 groups of butane, this one and this one, lie far apart from each other. Hence, this is the most stable conformation of butane because there is least steric strain and least torsional strain as well. To get the different conformations of butane, we have to perform the rotation operation about the carbon 2 and carbon 3 bond. This is the C2C3 bond about which we have to perform the rotational operation. So for this, we will keep one of these carbon atoms fixed. Say for example, here we'll keep the third carbon fixed and we'll perform the rotation of this bond like this. So starting with the staggered conformation of butane, we will rotate the molecule by 60 degrees to get this conformation. As you can see, this is a staggered conformation for butane because this hydrogen is being eclipsed by this methyl group. This methyl group is being eclipsed by this front hydrogen, and this hydrogen at the back is being eclipsed by this hydrogen. But since this methyl group and this methyl group on the back are not completely eclipsing each other, this typical eclipse conformation is called partially eclipsed conformation. We continue to rotate the molecule by another 60 degrees to get this type of conformation here, as you can see. In this type of conformation, the methyl groups are coming close to each other. Although this is a staggered conformation, as you can see, because all the bonds are clearly visible on the two carbon atoms, all the bonds are visible, all the hydrogens are visible, both the methyl groups are visible. But this methyl group lies in close proximity to this methyl group. Hence, there is an increased steric strain as well as an increased torsional strain in the molecule, which increases the energy of the system. This kind of staggered conformation is called as gauche conformation. And it is not a fully staggered conformation. The name given to it is gauche conformation. We will continue to rotate this carbon-carbon single bond further by an angle of 60 degrees down to get another eclipsed conformation like this. This is a fully eclipsed conformation of butane, and it has a very high energy because in this eclipsed conformation, the two methyl groups are completely eclipsing each other. The steric strain is highest in this case. The torsional strain is also highest in this case. This is the fully eclipsed conformation of butane. As we continue to rotate the molecule this side to complete a full rotation this way, we got another gauche conformation, which is a partially staggered conformation of butane. This gauche conformation is similar to the previous gauche conformation, and they have equal energies. As we continue to complete the rotation further up by an angle of 60 degrees, we get another partially eclipsed conformation. Continue to rotate the molecule further up by 60 degrees, you get another staggered conformation. This staggered conformation is similar to the one we had started with, and so it has the same energy as the first one. This is where we stop the conformational analysis of butane, as we have reached the configuration, as we have reached the conformation from where we have started. Starting with the staggered form, which is also known as antiform, which has the lowest energy, rotation about the carbon-carbon single bond C2C3 generated a partially eclipsed form which has higher energy than the previous conformation. Further rotation gave rise to a gauche conformation which has a lower energy than its previous conformation. Further rotation by 60 degrees gives rise to a completely eclipsed conformation which has the highest energy of all conformations. Thus, the four conformations of butane are completely staggered antiform, partially eclipsed form, partially staggered gauche form, and completely eclipsed form. So far in these videos, we have discussed the different conformations of butane and how rotation about the carbon-carbon single bond, that is the bond between the second and the third carbon, can generate the different conformations. The conformations that we have seen so far are 6, but actually there are 4 of them. The first is the completely staggered antiform. As you can see in this picture, the first form is the completely staggered antiform. In this, the methyl groups are far apart from each other. That is how we describe an antiform. One rotation operation about this carbon-carbon single bond by 60 degree in clockwise direction generates the conformation 2, which is the partially eclipsed form. In this partially eclipsed form, why we are saying it's partially eclipsed? Because the two methyl groups are not eclipsing each other. Rather, they are eclipsing the hydrogen atom on the other carbon. So this is a partial eclipse form. It has a higher energy than the completely staggered antiform. Another rotation in the clockwise direction by 60 degrees about the carbon-carbon single bond generates this third form, which is the partially staggered gauche form. In this form, the methyl groups are lying close to each other, and the angle of separation between them, that is the dihedral angle, is 60 degrees. This form is more stable than the second form, that is the partial eclipse form, but less stable than the first form, that is antiform. Another rotation operation about this carbon-carbon single bond by an angle of 60 degrees towards clockwise direction generates this form 4th, which is called the completely eclipsed or syn form. in this completely eclipsed form, as we can see, the two methyl groups are eclipsing each other. That is, the one that is on the front carbon atom is hiding the one that is on the backside carbon atom. This is called complete eclipsing of methyl groups. Because of complete eclipsing, there is high torsional strain in the molecule as well as high steric strain, which arises because the electronic clouds of the two methyl groups repel each other, and they are bulky, so they require a lot of space, and hence they cause a lot of strain in the molecule. And we have discussed the three types of strain before in the conformations of ethane and conformations of cyclohexane. So strain is highest in this case, hence this conformation has the highest energy. Another rotation in the clockwise direction by 60 degrees generates another form, that is fifth. Now this fifth form is a gauche form. As you can see, this fifth form is identical to the third form. So third and fifth have same energies. Another rotation by 60 degree in the same direction, that is clockwise, generates the conformation 6, in which the methyl groups are eclipsing the hydrogen atoms on the other carbon atom. This conformation 6 is similar to the conformation 2nd, that is, these two are the partially eclipsed conformations. So, although a complete rotation about the carbon-carbon single bond generates 6 conformations, but actually there are 4 conformations of butane, that is anti, partially eclipsed, gauche, and the syn forms. Further, just by having a look over the energy profile diagram of these conformations, we can see the anti form has the lowest energy because all types of strains are minimized here. The reason is that the two methyl groups are opposite to each other and they are far apart from each other. So they cause not much of strain. In fact, all strains are minimized here. So the energy is lowest and this is the most stable form. Consequently, when we continue to rotate the molecule, the energy increases, reaches a peak where we get the partially eclipsed form, second. Further rotation leads to decrease in energy of the system because we are going to get the gauche conformation, that is the third form. Further rotation causes the energy of the molecule to increase till it reaches a peak where we get the completely eclipsed conformation, and as you can see from this diagram, it has the highest energy of all conformations. Further rotation of the carbon-carbon single bond in the eclipsed conformation leads to decrease in energy of the system and it attains a lowest value where we get the gauche form again. Now these two gauche forms, as you can see, they are identical but they are mirror images of each other, but they have same energies. Again, performing this rotation operation further, energy of the molecule increases, reaches a peak, and we get the eclipsed conformation. This is again a partial eclipsed conformation. As you can see, it is similar to the second form, second and sixth. These two have the same energies. Further rotation leads to lowering of energy of the molecule and we get back the anti-conformation. This anti-conformation is identical to the first anti-conformation from where we had started the rotation. Thus, summarizing, we can say that the most stable form is the anti-conformation because it has the lowest energy, while the completely eclipsed form, that is fourth, which is also known as the syn form, has the highest energy and hence it is the least stable of all conformations.